Good afternoon, everyone. Hello. Can you hear me? Good afternoon. Yes. Okay, so you can hear me clearly, right? So how are you all? Everyone, how are you?
But your voice is
Good.
far, like I barely hear you.
Sorry, you can't hear me properly?
No, I can't.
Really?
Yeah.
My voice is not clear?
It's far.
It's far? Okay.
Yeah.
Let me check. Why is it like? Should be fine. Let me check my...
Maybe from me. I will even come back.
Is it okay for all of you or only for one student's problem? Is it okay for all of you or only one student? Now is it okay? What's wrong with my mic? Hello? Is it okay now?
Yes.
Yes, okay. You can hear me clearly, right?
Yes.
Right.
Okay. So, can you see my screen?
Yes.
So this is today's lecture. Actually, I had some emergency family problem, so that's why I'm taking this class online. But it had to be in campus. Next week, inshallah, we will have in campus. So today we are going to perform the simulation experiment for experiment number 1. And I will explain you what is diode and what are its characteristics. So have you studied about diodes in your lecture?
Yes.
Do you know what is diode? Can anyone tell me what is diode? Diode. So diode is a two-terminal device. It has one positive terminal, one negative terminal. Okay. So this one gray part is shown here also. This gray is negative and this black is positive. Okay. The symbol of diode is this one is positive. This is negative. Okay. The main function of diode is to allow the flow of current in one direction. This is the functionality of diode. Diode is meant to do this action. And then when it is, for example, okay, I write it like this. If I connect battery here, positive with positive, negative with negative. So tell me how this diode is connected. This is positive, this is negative. So this is forward bias because positive is connected with positive. This is forward bias. This will allow the flow of current in this direction. If I just let me erase it. If I just make it so if I just make it negative, and then this becomes positive. So now negative is reverse, yes. And now in the reverse, it gives very, very high resistance, almost infinity to the flow of current. So it acts as an open circuit in reverse bias. So no current will flow in reverse bias. It blocks current in reverse biased. So this is the main functionality of diode. Is it clear to all of you? So that what is diode, why it is made, and what is its functionality? Clear?
Clear.
Okay. Then now So the graph of diode, so for example, this is the symbol of diode. So if I connect it here, so this is positive, and then this smaller one is negative. Okay, always this positive is, if this side is long, so it means this is positive. So this is positive. Now diode is forward bias. There is almost zero resistance in forward bias. So what happens? And then diode has a threshold voltage of 0.7 volt in case of silicon. Mostly they are made up of silicon. And in case of germanium, it is 0.3 threshold voltage, VT threshold. It means that when this 0.7 volts is achieved, after that diode starts conduction infinity, almost very, very high amount of current. Exponential, actually, we can't say it infinity, we can say it exponential. Okay, so a very low amount of current will flow unless this threshold voltage is achieved. What does it mean? For example, if I start from 0, then 0.1, 0.2, unless I reach 0.7, very low amount of current will flow. When this is reached, then it will rise exponentially. Is it understandable? Yes. So this is the diode equation when it is forward biased, that E means exponential, that the current flow is exponential. That's why this equation has this exponential function. And when I connect this diode in this, so negative here, positive, negative. Now reverse bias, and then the resistance is infinity. So very, very almost zero current flows. And then when breakdown voltage, which is for the, in this case, the diode which we will use is for that almost it's 1000 volt. When this voltage is achieved, it means diode is burned. So for that, then when this breakdown voltage is achieved, then current will flow in negative, otherwise it will block all the current. Okay, clear? So then, so if I have this circuit, does anyone can apply KVL on this circuit? Very easy circuit. Can anyone apply KVL on this? This one. So minus,
10
yeah, okay, minus 10.
plus IR
Yes,
plus 0.7.
yeah, great.
Equals
0.57 equals to 0. Yes. And then minus 10 is equals to IR. Let's suppose this is 0.7. Let's suppose this is almost equals to 0. And if I put R is equal to 10K, so how much will be I? 10 volt divided with, this will be plus 10 volt divided by 10K. It will be 1 milliampere. Yeah, 1 milliampere. So let's say this is 10 volt. So here it will be almost 1 milliampere. So then if I join this point with this point, and then this is the forward conduction of diode, then this is the point where this is a common point between two curves known as quiescent point. Then I get a common point between these 2 points. Is this point clear? What is quiescent point? When current and when voltage and current has the same common point, or when they touch the curve at the same common point, that point is known as quiescent point. Okay, clear? And then this is known as load line. This line is known as load line. It's written here also. Okay, then static resistance. What is static resistance? For example, if I give DC, for example, if I give DC voltage to a resistor, positive. So if I give DC resistor to a DC voltage to a resistor, then that resistance is known as static because it's stationary. Because the DC voltage is stationary. What is DC voltage? DC voltage is like this. For example, it has one common, one constant value, and then this constant value is same for all the time. It doesn't change like AC. So this is static resistance. So resistance equals to V by I by Ohm's law. Okay. Then What is dynamic resistance? Dynamic resistance, it has AC voltage. Are you familiar with AC? So this AC is changing. So this is known as dynamic resistance. Okay. Okay, then this is your lab experiment. So this you are already familiar with multisim, right? Multisim, are you already familiar?
Yes.
We did it in 101 also. So this is the forward characteristics of diode. You see diode is connected like this. It means this is positive side, this is negative, and then here positive is connected. So positive with positive, forward bias, forward. And this, what is this? This is negatively. Here it is positive, here this is negative. So which direction? Reverse. Reverse biased. Okay. Now I explain you in 101 also. You see what kind of connection is this? Here.
Parallel.
How? How is it parallel?
No, serious.
Yes, this is series connection. How? Because for example, there is one line here, one line here. If I connect something here, this will be a series connection. But if there is one line here, complete one line, then if I connect something in between that line, now you see the line is here, there is a connection. Here, this is parallel. Here, this is series. So current is always measured in series. Now I broke the line connection between, for example, this why I break this and then I connect meter in between. It means this is a series connection. Now for the voltage, I just connected this meter. This is voltmeter.
Parallel.
Yes, this is parallel. This is voltmeter. Voltage is always measured in parallel.
Parallel.
Okay? Yes. And current is measured in series. Okay. What you have to do is, let me open multisim. Multisim. So this is the app. You already have it. So this is the multisim software. So from here, we will take a DC interactive voltage. This one. Go to power sources from here, then here signal voltage sources, and then here DC interactive voltage, and then this one you will take it out. Okay. Then what you need? You need a what you need next? You need a resistor, 100 ohms, and then you need a diode. That's it. So what you need is resistor. How you can get the resistor from here? This one. How much? 100 ohm. So this one I will put here. Then I need ground. So already you are familiar with these things, so that I don't have to put so much time on this. Okay. And diode I will take from here. Place diode. So then the number of diodes should be this one, 1N4007. So I will write here 1N4007. So this one, 1N4007G. This one diode, we will take it out. Then we are done. Now I will rotate it to 90 degrees. Then I will connect this wire here. Then I will connect this here. Then I will connect this here. Okay. Now I want to measure the current here. What I will do is I will go here. From here I will take multimeter. Okay. And then another meter I take. So, okay. So this is simple. If I want to measure voltage, just click this V here. And then connect this here. Connect this here. This is parallel connection. For the voltage, it's always very easy, right? Then for current, I have to break this line. Break this line. Then connect this in series here, here. Now this is a series connection. Double click this and select ampere here. So then double click this one and then choose the maximum value. So if you go to your lab sheet, so do you know where is this lab sheet? If you go here in the Moodle, go to 112 Spring here. Okay, where is, yes, this one folder, EE112 lab experiment exercises. Here the data sheet is also uploaded here, and then experiment 1 is here. The lab slides are also here. So download this one, you will get this. So if you go down, okay, so this experiment we are doing now. So minimum voltage should be 0, maximum should be 2. Or let's also from here you can see that we will be increasing the voltage from 0 to 2, and then how much increment? 0.1. So go back to your, okay, so maximum value should be 2, minimum should be 0, and increment should be 10%, means 0.1. Actually 0.1%. Okay, so now start from here. 0 will be 0. Then you can increase it from here. Actually, I should make it 10%. Yeah, 0. And with the cursor, you can change it. 0.2. Should be. Just a minute. Okay, let's make it minimum value should be 2. Should be 5%. Then I check. Yes, now this is fine. So you have to put the increment of 5% so that you can fill this table, because there is an increment of 0.1. Okay, so if you choose increment of 5%, then you will be able to make a difference of 0.1. So change this 0.1. Okay, now run it. When you will run it, then you will double click this one here, and you will double click this one here. Okay, so this is 0.099, it means 0.1 volt, and then this is the current 52 nanoampere. So you will get these readings, you will fill this table. For the voltage, you will put, for voltage you will put this value here, and for the current you will put this value here. Okay, so you will fill this table. Okay, then when you are done with it, then what you will do is you will copy this, these values, you will put them in Excel here. I have already put almost similar to this one. right? Is it similar? Check this one. Are you listening? Hello?
Yes, miss.
Okay, so can you see that this is almost similar to this one, forward? So it means that my values are correct. Then what I will do is I will just flip this diode. Okay, so stop simulation. So I will just, okay, Control X. And I will just flip its direction. Here, now this is reversed bias connection. So what I have to do is I will change the values. So 0 to 2 will be the same. And then what I will do is one thing I will change here is I will just flip it. Okay, not vertically, flip it horizontally. Okay, and this one I will just make it here. Just this small change you have to do in the reverse bias. Just flip this diode and flip it. Now start measuring 0.1, run the simulation. Now check how much current is flowing. So 6.22 nanoampere, and this is almost 0.099 millivolt. It means almost 0.1 volt. Okay. Sorry, this is 99.9 millivolt. It means 0.099 volts. Okay, then you will take this value. So you will take these values, you will fill this all table. Okay. And then at the end, you will copy this, you will go to the Excel. So you will put the values here, and then you will draw this graph, this one. Okay, your graph should look like this. It's almost zero. You see, the current, maximum current is almost 7.5 nanoampere. So is it zero? Yes, it's zero. Nanoampere means zero current. Nano means 10 to the power minus 9. So this is it. And then please solve this lab here. And for this experiment, the second one here, this I will give you a demonstration in the next class for the hardware. You are already familiar with NI Elvis board. So we will use this hardware, same we were using it for 101 also. We will use this hardware to implement our circuit. So first what we will do is I will put a resistor here. Then I will connect a diode here. And then I will make a connection. From here, I will connect it to positive, and then from here, I will connect it to negative. So simple. It will be a very simple connection. So only one resistor, then here diode, and then we will perform this experiment in the class. I will give you very small demonstration about it. You are already familiar with it. So here you see, I connected this diode in the NI Elvis board, this resistor and diode, and then I will repeat these step. I will change the voltage, and then I will check current and voltage. Similarly, I will then make the diode reverse biased. So how I will connect it? So with this, I will connect positive terminal. With this, I will connect negative. So then it will be reverse bias. Then I will fill this table, and same I will use. So you see, this is simulation result. These are the hardware results. For the hardware, I will put the values here and then draw the graph, this one. And then for the reverse bias, I took these readings from the hardware, and then this is the reverse biased characteristics. So then at the end, you have these three questions. So these questions are what you have to do is go to Moodle, download this data sheet. If you open this data sheet, Okay, so here are the specifications of the diode. So this okay, let me open this in another software so that I can give you a demonstration. So which diode we are using? Okay, so we are using this diode number 1N4007. Okay, so the question is the maximum referring to the associated data sheet which is attached in Moodle. So the maximum repetitive peak voltage for the diode. So how much is the peak voltage for the diode? So so peak maximum forward voltage is 1.1 volt. Okay, then what is the other question? The typical value of reverse current when the junction is at 25. So reverse current, so maximum reverse current is here, and at 25 this is 5 microampere. Okay, then you will go back with the constant input voltage of 1 volt and a given load resistance. This question you will solve using this slide number, this one. Okay, how you will do it? So 1 volt voltage is equals to 1 volt, resistance is equals to 1k. So what is and then draw a load line characteristics. So you know that what is load line characteristics. Sorry, this is not like this. So you know that diode in forward bias is like this. Okay, so if you go to, for example, 1 volt here, 1 volt here, and then from here you can get the current reading. How much is the current? Because you have V, I is equal to V by R, and V is 1 divided by 1K, so 1 milliampere. So here let's say 1 milliampere is here, then so sorry, not this one, and then you will join these two points. Okay, so forget about this one. Yes, so here this is your Q point. Okay, so this is the diode operating point, which is known as Q point. You can just tell me this is diode operating point. Okay, is this clear? Is this clear to all of you?
Clear, clear, miss.
Yes.
Okay. Then question number 3. Can anyone answer question number 3? It's very, very easy. It's asking about the static resistance. This one, static resistance. So if you go to the slide, I told you what is static resistance. Okay, so can anyone tell me, if voltage is 1 volt and if current is 1 ampere, how much is static resistance? Tell me. If you have V and if you have I, can you bring the value of R? You know, by Ohm's law, V equals to IR. So how much will be R?
1000.
R V over I.
Yes, and then V is 1 divided by 1
1
milliampere.
kilo ohm.
Yes, 1 kilo ohm. So these are 3 questions. So for these results, you can use my results, which are already given in the slides here. Just use my results, it's fine, but draw your own graphs and then 2 graphs separately, because here I draw 2 graphs together. You can draw 2 graphs separately like this. Here, these are separate graphs for the reverse, for the forward. I just made a collective graph to show you, but take these results and fill these tables, it's fine. And just submit your lab report. The deadline is here. If you go here,
Miss,
I already have, yes. So 1 minute. Yeah. Here is section 3. Here just 21st of February is your deadline. Submit your lab report. And for the hardware experiment, next time we are going to perform the second experiment. And I will give you a demonstration of this experiment number 1, hardware implementation, for like maybe 15-20 minutes. But it's very easy. Okay, you are already familiar. So, but submit your lab report. Okay.
Miss,
And yes,
submit lab report with the pre-lab and the 3 question of experiment only.
let me tell you. So this is your experiment, right? So what you have to do is go down. It starts from here. Yes, you have to do pre-lab, both of these, fill these tables, make graph here, make graph in Excel like me. I did it. So you see, I did it.
Yes.
Copy these graphs, put them, you can delete this and you can copy your graph here for the forward bias, and down there you can put your reverse bias graph. And then you can come here for this. As you didn't do the hardware experiment, but fill this table using my results, and then you can put your 2 graphs here, and then solve these 3 questions and then submit your report. And one more thing is that I will make you in groups. So because then you can submit same lab report. So if I just 3 students per group, is it okay that I make your groups, or you want your own groups? So this one, there should be 19 students. So I will make your 19 students. So 6 groups I will make. I will put the list on the Moodle, and then all of you will be submitting the same report, so that I will not deduct marks for copying. And yes, that's it. So I will make you in groups. Okay. Is it clear?
Clear.
Okay, so now I'm going to take your attendance, and tell me, Suhail is present?
Yes, I am here, Dikko.
Walid is here?
Yes.
Salman? Absent? Rahaf?
Yes. I am
Dari?
Salman.
Okay, Salman, okay. And Dari is here?
Yes, miss.
Zahra?
Yes.
Okay. Khalid?
Yes, doctor, yes.
Okay. Sheikha? Absent? Okay. Faisal?
Yes.
Shahid? Shahid?
Yes.
Okay. Anwar? Anwar is not here. Reem?
Yes. Yes,
Hadil?
Anwar, I am here.
Okay. So Hadil?
Yes.
Claudia?
Yes.
Mariam?
Yes.
Said? Said is not here. Mishail? Not here. Jana?
Yes.
Who? Mishail?
Yes.
Okay.
Yes, I am here, Mishari.
And Said? Okay. Mishari? Mishari is here.
Yes, I am here.
And Mishail Marzouk.
Yes.
Okay.
Yes.
Okay, so these 2 students are absent, Said and Sheikha. Okay, so see you in the next class. Please, all of you come to the campus, because
Doctor?
Yes.
My name is Fatma. I am the other section. I told you I am in hospital.
Okay, 1 minute, Fatima. Which section you are?
Wait, let me check my section. I am not sure.
Tell me.
Section 1.
Here. Did I put your absent?
Yes, I think you said you will be put me in absent, but I talked with you yesterday in email, and you said it's okay if you come online in this lab. I will
Yeah,
be
yeah, I
take it
told
off.
you. Yes, I told you. Let me
And
just
I
check.
told you I will be give you my medical paper and my report,
It's
everything
okay.
when next week.
Monday.
inshallah.
Okay, I just correct your absent. Yeah, this one?
Fatma Fahad Naif 192056.
Okay, yes, this one. Fatima, I correct your absent. So, please, all of you come to the campus. Fatima, please come to the campus for the experiment because it's very important that you'll
Inshallah, okay.
have some experience of hardware. So, see you in the next class. Please submit your report and have a nice weekend.
Thank you,
Miss,
Doctor.
Yes.
can I use the online multisim?
You can use, but then you will not have these features in multisim online. So better that install this offline. All the instructions are here on the Moodle.
Okay.
Here, everything is here, downloading and installing multisim. This page has all the information how to download the multisim software. Okay.
Okay, thank you.
Okay, any questions? This video I will upload it on Moodle. Okay, so I will upload the recording of this lab in the Moodle so that you don't have any problem. You can watch it again and again and to see the how I perform the experiment. Okay.
Thank you, Miss.
Thank you. Okay. Bye bye.
Bye bye. Have a nice weekend.
You too.